So this is what's known as the transformations of quadratics, right? So us taking the base graph, like what we've been talking about, and then moving it around. Right? That's all we're doing. It's transformations. Okay. So far, we've seen this before, right? Yes. Okay. That's just the base graph. What does the base graph look like? I always do the base graph in black so we can see. 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. Right? This is what we always do. Okay. So you have to know this. No questions asked. You just have to know what that graph looks like and what the points are, right? Otherwise, we can't do any of this work. So that's your starting point. You need to know this first and foremost. Okay. Now, we've got some things we can answer about that particular graph, right? And any other parabola. Yes.
Can you explain it again because I missed it?
Okay. So this has to be known. You have to know this graph, right? Which we spent a whole bunch of time on the other sheet. It's always the same values. It doesn't change. It changes when we start putting stuff, when it transforms. We'll use the word transforms here, right? From this to this. And then some of these start becoming numbers. Like there was a number here and there's been a number there, right? That's when we started moving the graph around, right? But this one, the black graph always is the black graph. It's always just x squared. It always has those points, those 5 points that you need to know, right? So then we can start answering questions about this graph, okay? So one of the questions we like to answer is like its direction of opening. Is it opening up or is it opening down? The base graph. It's opening up, right? So it's smiling, so it's opening down. We kind of like say if it's frowning, it's opening down. Frown down. Yeah? Okay. It's not frowning, so it's not opening down. Okay? It's opening up. So we get to write that there, right? And then what's the vertex? Do we know what the vertex is from grade 10 or any other math course you've ever taken? What's the vertex? It's the axis. Okay, yeah.
Like the first point.
It's the highest or lowest point on the graph, right? So in this instance, the vertex is going to be right here, right? Because that's the lowest point. And then you could say, okay, the vertex actually it's a point, and it's a point that could we could dignify it with an XY, right? So we could say, okay, what's 0, 0 is where the vertex is. It's right at the origin, right? And then it has an optimal value. Every parabola has an optimal value, right? If the parabola is opening up and it reaches a smallest value in that instance, is it a maximum or a minimum? This graph. Maybe we should just ask this in a way. Like, so if I'm coming along here, what is this point? A maximum or a minimum? If you were on a roller coaster and it was doing something like this, would you reach a maximum or a minimum at that?
Maximum.
Okay, so it's not, but the graph doesn't look like this, right? It's the opposite way. So it's not going to be a maximum, it's going to be a minimum because it has a low point, a minimum, right? So we could say it's a minimum, right, at 0 when x equals 0, right, in this instance, right? So it's a minimum at x equals 0, right? Is that okay so far? Just kind of labeling things on the parabola, okay? And then axis of symmetry. Do you know what the axis of symmetry is? Where the two halves meet. Sure. Right? So where the two halves meet is what we're saying, right? So right in the middle, it's like the mirror, right? Where could I put a mirror on the graph? That's what the axis of symmetry is, right? So we're going to go, okay, well, the axis of symmetry could be right here, right? right? How do we denote that? What are all the x values along this line? This green. Like if I plotted a whole bunch of points along here, what would be the x values? 0. So I could say that the equation of that line, it's a vertical line, we could say is x equals 0. Because every point along the line, right, doesn't matter what point I pick, the x value is always 0 along there. Right? Everybody okay with that? What's the y-intercept? Where does it cross the y-axis? Is 0. This one's not interesting, right? It's not interesting because it's the parent function. Things get interesting when we move the parent function around. That's just what you're trying to do today. That's the goal, right? So it's the y-intercept is 0 and the x-intercept is 0. Okay? It's because the graph is crossing through the origin. That's the only reason why that's the case. Right. Is everybody okay? Okay. So we should know what happens with this a value, or what this a value controls from yesterday and everything else that we've been talking about, right? Do we know? Right? So these would be the a values. You remember doing this? Stretches or compresses. Very good. Very, very, very good. Those are the terminology we want, right? So A, that's kind of what it's saying here, stretches. Or it should say compressions too, but that's the A value, right? Okay. So you guys played around with Desmos yesterday. This kind of fits well, right? You can type in the general formula, right? And you could add a slider, which I haven't shown you how to do, but we know how to do this, okay? So for all of these, you're just going to, it's good practice just to draw the original always. That way you get in like the habit of doing it and you know what the 5 points are, right? Because you'll get a mark for that. Just drawing the base one. So I always know it's 0, 0, 1, 1, 2, 4. And then it's symmetrical about the axis, right? So there's my base graph. That's y equals x squared. And then what do I have to do to that? What's this equation telling me to do? What's it saying to do? What do we have to do? You guys take a minute. You know, I know you know how to do this because we spent 3 days on this. Okay. What has to happen to this graph? If I have a 2 here, what is that 2 doing? Close. You're right. It's okay. That's more than anything anyone else has said, Taylor, so that's okay. Right? If we were going to move it, Taylor, if we were going to move it, it would be +2, which isn't the case. Okay? It's in a different spot, so it's doing something else. What is it doing? It's stretching. It does say right there. Very resourceful. Right? So, it's out front, so it's like us physically taking the top of the graph, the base graph, the black one, and I'm going to pull on it by a factor of 2. Right? So it should get skinnier. Right? So if I'm going to pull on it vertically, then their y values are going to get twice as big. Right? So basically that means, okay, this point right here is 1 unit away from the x-axis. So I pull on it twice as hard. It should get twice as far away, right? Or if I stretch it, right? So it's 1 away, so then that means it's going to go to 2 instead, right? Same thing here. This one's 1 away, so I'm going to pull on it with a factor of 2. It's going to go there, right? This point here is 4 away, right, from the y-axis, which means if I multiply it by 2 or I pull on it by a factor of 2, it's going to go to 8, right? So it's going to go all the way up here. And the same thing on the other side, right? So effectively, we get what we were talking about is the graph gets skinnier because I've pulled on it vertically, right? I took the y values and I multiplied them by 2. Okay? So then I get to go over here and like you're at the very least you're getting practice writing out the base parabola, right? 2, 4. Negative 2, 4. All right? There's your base parabola. What am I doing this time though? What's different from this question to this one? What's different, Taylor? What's different between the two equations? I have a 2 here and I want to have 1/2 there. Yeah, it's just going to half the amount this time. So instead of multiplying them by 2, I'm going to cut them in half, right? Which just means, look, okay, I'm going to go, this one's at 1, so I'm going to go half as far now, at 0.5. Same thing here. And then 4 is going to get cut in half to 2. So what happens to the parabola? It gets pushed down. It gets wider, right? It's wider than the original. Okay? Make sense? Nothing too crazy yet, I don't think. This should all still be kind of like what you were playing around with on Desmos yesterday, right? The last one introduces the second of 4 transformations that we are responsible for, okay? So if you know how to do these 3 questions inside out, you're halfway there. And I honestly think the other 2, individually, they all seem easy. It can be a little bit daunting with all 4 mixed in there, but I will show you the process in which we do things one at a time, and it makes the whole process look really, really easy, right? And that's the end goal. The end goal is just, am I able to transform parabolas? That's your learning goal, right? Based on a series of things, or you're just recognizing different things in the the equation, right? So this one here, again, let's just draw the parabola, okay? 0, 0, 1, 1, negative 1, 1, 2, 4. Every single time. This is your first step, every single time. Right? Now, what did we do last time there was a 2? I multiplied them by 2, right? The y values. So same thing this time, except what am I multiplying by? Negative 2. So all the y values are going to get twice as big, and then they're going to become negative. Right? So I could do this in 2 steps, right? I know what the first one should look like. It's the exact same as this, right? The other one. I like doing these in multiple steps because I can see each of the transformations, right? So there's the graph from before. We already did this one. This is y equals 2x, right? But there's one more piece to this. There's a negative out front. So then I just take all the y values and I make them negative, right? So the whole graph essentially just gets reflected this way. This one becomes negative, so I'm at positive 2. I now go to negative 2. Positive 2 to negative 2. Positive 8 down to negative 8. Positive 8 down to negative 8. There's the graph y equals negative 2x. So if you do them one at a time, right, then you can keep track of them. And I like doing them in different colors. So I can see the black is the original, red is after I multiplied, I stretched it by 2, and then the blue is the reflection, right? And I can see exactly what I've done every step of the way. Is everybody okay with that? That's half of the work. It's honestly, like, the other two are like simple addition, subtraction, not even any multiplication. So if you can do that, you're well on your way. Say that again, sir? Okay. Okay. Now, these look a little bit daunting. They're just rules, okay? And I will read the word. They're just symbols and they mean words and that's it, right? So, this is saying if A is greater than 1. What was an example of where A being the number out front, if it's bigger than 1, so if it's 2, if it's 1.5, if it's 10, what did I do to the graph? I stretched it. I made it skinnier and I stretched it, right? So that's what you get to write there. The relation has been stretched vertically, right? So I'll even put example, in case the word, you don't like the notation there, example A equals 2 or 10 or 50, whatever. Okay, the next one, all it's saying is I'm going to stand here in the middle. I'm going to say A is bigger than 0, but it's less than 1. What would be an example of something being bigger than 0 but less than 1? It's like kind of a mind twist, right? So it's got to be bigger than 0 but less than 1. 0.5 is right in the middle. So it's either going to look like it's going to be a decimal or a fraction. What did that mean? I cut them down, right, by whatever the factor is. Or I push down on the graph so it got compressed. Okay? So this will go here with this one. Okay? So the relation has been compressed. And there's only one other one. Right? These are just, this is like a box of rules for you. Okay? So if you're confused about something, you go here and look, okay, well, what happens, right? Or what's happening based on what the A value is, right? Okay, what's the last one? This is saying if A is less than 0. What does less than 0 mean? Negative. So if A is negative, what happened to the graph? It's the blue one here. I flipped it upside down. Now it's frowning. This is opening down now, okay? Frowns are upside down. So the relation has been reflected in the x-axis. Okay? Those are 2 of your 4 rules done. As long as you have no problems with that, then you're laughing. Because the other 2 are going to be okay. Okay? So, let's look at the other 2 before we start jumping into the table here. Okay? We'll look at the other 2 variables that are here. Let's talk about h. If we had to put another whatever number of letters on the end of h, what do we figure h is controlling in this equation? Give me a word that starts with h. That's related to what we've talked about the last 3 days. What? Horizontal. So it's what controls the graph moving left or right, right? So if I see a number here, okay, if I see a number there, it's either moving the graph left or it's moving the graph right, okay? And by process of elimination now, what's the only other thing we can do to these graphs? I have stretching or compressing, I have flipping, and then I have moving left and right. There's one more thing I can do to them. We did compressions and stretches, right? There's one more. Up and down. That's the number on the end. K, which I pretend in French, the word vertical starts with the letter K, which it doesn't at all. I just made that up to make me remember. Right. Okay, so this is the vertical piece. Okay, you guys can scratch this TX thing out. We don't need that. That's not for you. Okay, this is all we're going to do. Those are your 4 things. Reflect, stretch or compress, left or right, up, down. That's it. Okay, do you want me to summarize it somewhere? So you basically get this generic looking equation. Okay. Right? Does everybody like my color coding? I think that makes it a little bit easier. It's wonderful, isn't it? Makes it very easy. Okay? And then the only other thing you can do is if there's a negative out front, right? So if this magenta negative is there, then you're reflecting. If it's not there, you're not reflecting. So you really only have 3 things to know, right? And that's it. Right? Are we good? So let's go up here. We'll try a couple examples, and then I'll give you some work. You guys can plug away at it for the period, okay? So let's look here. And I will identify these with you, okay? We'll color right here. So I will color code this so that you guys can see and make sense of it, okay? So here's the box. Here's the equation that the generic form, right? Do I see an A value down here? I'm looking at this one here. The 3, good, okay? So I see the 3, okay? Do I see anything else? Let's color code it. Do I see anything else? K, what does K do? It's moving it up and down. Okay, so for this, I'm just going to fill out this box left to right, okay, for this row. I don't see a reflection, right, because there's no negative out front, so that's a no, right? I do see a stretch or compression. It's vertical. Stretch by 3. Okay. I don't know why that mapping notation's still in there. You guys can scratch that out in a sec here. But is there any translations? Vertical. Down 2. Okay. I will go down to the graph now. So you don't need this. This was this T. See this thing here? This is what's mapping notation. You don't need this, okay? I deleted it. I don't know why it's back on here. Okay, so we don't need that. Okay. Now if you want to, yes, everybody, go to student services here. This, okay. Here, this is for some of us that maybe still need this. I don't need to do this. I'm going to show you the way to do it without it. But if you need to, you can write a table of values here, right? So you get X and Y, right? And then this is just like the booklet I gave you, 1, 2, right? If you still need this, you could write your tables of values. I know it's 4, 1, 0, 1, 4. And then you could plug in the X values into the equation and get out new ones, right? You can do it that way. It's way more time consuming, and you have this notion of, what if I type into my calculator wrong, I get the wrong graph. We've seen that a little bit, right? I would prefer you to ignore this, the new points, know what the old ones are, because that's important, but then just apply the transformations accordingly to what you see, okay? We got all this down, this box? So if I jump down to the graphs, are we going to be okay? Okay. Okay, so again, what's the first step? Draw the original. 0, 0, 1, 1, 2, 4. Okay. There's my original. Okay. Now this particular question asked me to do 2 things. Okay. If I go up here, I'm going to rewrite this out here. Okay, that's the question from A. Okay. Now it told me to do 2 things. Okay. We already identified what those 2 things were. Vertical stretch by 3, move down by 2. Okay. So I'm going to do this graph in red because that's what I started with now. 0, 0 stays the same because if I multiply 0 by 3 or anything, it's still 0. This one here is at 1, a height of 1. I need to multiply it by 3 because that's what it's telling me to do. So I'm going to go from 1 to 3. Same thing on the other side. I'm at 1. I'm going to go to 3. And then I'm going to go to, I got 4. 4 times 3 is going to be 12. So it's just going to go off the graph a tiny bit, off the grid. Okay. Okay. And same thing on the other side. What graph did I just draw? Am I done? Remember what I do? I do it in multiple colors or multiple different styles. Sometimes you could use dashes. You could use you could just need to signify different graphs, right? So however you choose to do that, if it's colors or dashes or dots, whatever, right? I have only done one piece of this transformation, right? The question was 3x minus 2. I've only done the 3x piece, the 3x squared, right? That's that graph. Right? So the other piece I have to do is take that red graph now and move every point down 2. Right? So I'll do that in blue. Right? So this point was at 12. I'm going to move it down 2. It's going to go to 10 now. This point was at 3. I'm going to move it down to 1. This point was at 0. I'm going to move it down to negative 2. This point was at 3, down to 1. This point was at 10. I'm going to move it down, or sorry, at 12, down to 10. Then I can connect the blue dots. There's my final product. That's what happens when I multiply the base graph by 3 and then move it down 2. Okay. Did anybody pay attention to the order in which I did that? It's important. Okay, it makes things a little bit easier. If you always start on the left, just like reading a book or an equation or like a sentence, I'm going to start on the left with the furthest left transformation, and then I'm going to go to the right. Yes.
Whites then.
See this point here? It went off the graph. It's not great. This point right here was at 12. It's 12 minus 2. 10. Okay, so I just physically, can you see the difference between these 2 points? I went from 12 and then I subtracted 2, and then the blue is the 10, right? You see that? So if the red point is at 12, then I subtract 2, then the blue point's at 10 because I subtracted 2. Saved it, all these points, right? There's another one. There's the original, the red. It's now 2 lower, 2 lower, 2 lower. Because I subtracted 2, I moved everything down 2. Okay? You want to do one more? This, what part are you confused with?
There's 3 squared where they give the following 3 times x, not x squared.
Yeah, so like the black graph is y equals x squared, right? And then the equation told me to take the black graph, x squared, and multiply it by 3. So they're y values, right? So you see the black graph went from 1 up to 3, right? So it got vertically stretched. I made it skinnier by a factor of 3. And then I moved it down 2 units afterward, right? So you got the black graph, which is the base. The black graph is always a black graph. And then the different colors are the different transformations that you apply to it. Okay? We'll do another one. There's 4 of them to do. We'll hopefully get it by the end. If not, we'll just keep doing questions. We'll get it. Okay? So the other one, okay. First step, draw the original. 0, 0. I don't even care what the question is. You're always just drawing the same original graph. 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. That's always your first step. No questions asked, just draw those 5 points. Okay? Then you start doing things. So let's go up here. I'll keep all the work for this one right here, okay? On the right side here. So what's going on here? I see a reflection, so let's do that first, okay? The reflection, we'll do the reflection in a red graph, okay? So all I'm going to do is reflect this graph in the x-axis, okay? So just going to flip it vertically. So now it's frowning. Okay? Right? And then this one is at 4. I'm going to take it down to -4. Positive 4 down to -4. Alright. That's y equals -x squared. What's next? Like a book, what's the next thing? You want to see it? Sorry, I'll leave it. Okay, so all I did was take the original. It told me to flip it. So I flipped it. Make it frown. Okay, what's next? What's the next thing on the right? Here's where things get tricky. I'll do this one in green. What am I doing? I'm waiting for somebody to give me the answer that I want to hear, and then I'll correct it.
Stretch it down. No, left or right.
Left or right. Okay, so if I see brackets, that's a clue that it's horizontal, right? Because the H was on the inside of brackets. If there's no brackets there, then it's vertical. So that's good. I didn't mean for that, but here's the other piece. Am I going left or am I going right? Is my question.
So let's make it right. Right because it's positive.
Right, because it's positive, would be intuitive, but it's not the case. It's got to be opposite inside. It's the only instance, okay? If there's no brackets and you see a +2, then move it up 2. But if there's brackets and it says +4, it's got to go left 4. It's opposite. Opposite on the inside, okay? So, here's the new graph, okay? I'm going to take the red graph now, and I'm going to take every point on the red graph, and I'm going to move it left 4. Okay? So this one's at 0. I'm going to move it. I'm moving it left 4. 1, 2, 3, 4. Then I'm going to take the other one, the next one. I'm going to move it left 4 to -5. I'm going to take this one. I'm going to move it left 4. 1, 2, 3, 4. Take this one. 1, 2, 3, 4. Take this one. 1, 2, 3, 4. Draw the graph. Question over. That is now the graph of y equals -x plus 4 squared. Done. Okay? As long as you stay very, what's the word I'm looking for? Methodical. So you work left to right. You become aware of reflect, stretch, left or right, up, down. If you do it in that order every single time, be neat, be methodical, you'll get the graphs every single time. Will you make the occasional wrong sign or move the graph in the wrong direction? Yes. I'm not going to nail you on the test for that, right? Because I can see, I'll have my solution. I can pretty quickly see if you just move the graph to the left by accident versus the right. Okay? The idea is you have now like locked into your head reflection, stretch or compress, moving left or right, and then up and down. Okay? So if your graph was over here, somewhere, like if let's say if I did it in this magenta, if your graph was here somewhere, instead of the green one, you're probably still gonna get like 3.5 out of 4 or something like that, right? Because you knew to move the graph horizontally 4 units, you just went the wrong way. Not a big deal, right? Okay. Do you need me still? You want to do one more? You want to do a harder one? Do one more? I'll let you guys go. Okay. So let's do this one. So what's the first step? Draw the base. 0, 0, 1, 1, -1, 2, 4. If these points are wrong, your graph's wrong. That's why it's important. Because if you start transforming the wrong points, we're going to get the wrong graph. What's the first thing I need to do? Let's do it in red. We'll scroll up here and take a look. There's the A value. What is it telling me to do? It's less than 1 but bigger than 0. Cut it in half. Push on it. Squish it. So I'm going to cut everything in half. There's the 0.5. There's the 2. There's the 0.5. There's the 2. Right.
Not here today? I didn't think so. Does she look like again?
Curly hair. Curly hair right there.
Right, yeah. Oh, lovely. Do you know who Miss Dupuy is? Karina?
I can probably find her.
She's like the first office in the Google Student Services. Across the hallway from Student Success. She's the first one on that.
Tell her.
Yeah, she's not here.
Okay. That's the graph of y equals 1/2 x squared. What's next? What's the next thing on the right? Just keep going. What's next? Is it left?
No, right. That's negative.
Left or right? Which one am I doing?
Left.
Taylor.
Oh, sorry, I was looking at the wrong one. I see. Right.
By how many?
One.
So take all the points, move them to the right one. This one's going to go to the here. This one's going here. This is going here. This is going here. This is going here.
Wait,
Yes.
Yeah.
Yeah, I know. So, okay, I'll do that one again. You want me to do that one again? Okay, hold on.
What?
I gotta do it again. Okay, I'll make these points a little bigger too in red. Okay, can everybody see those 5 points? The big red ones? Okay. The red is the graph 1/2 x squared. Okay. The next one told me to do what? Are we watching? Are we watching? So the blue piece here is telling me I see brackets, right? So I know there has to be an H piece, a horizontal. So I have to move it left or right. Now remember, it's a bit of trickery going on. It looks like it's going left because of the negative, but it's not. It's going to the right because it's opposite, right? So I'm going to move it to the right one. Every point. So all these big red dots are going to go to the right 1 unit. So if I'm at 2 and I go to the right 1, then it has to go to 3.
Wait, is the bottom of the red one not supposed to be down? Like out of the half? Or do you not know that?
This one doesn't get cut in half because it's 0. What's half of 0?
Oh yeah, that's true.
It's still 0. It's just good. That's, yes. Just do it left to right, and then same thing if you stretch it, right? You can't, if you multiply 0 by 2, it's not going to get any bigger. It's still 0. Everything scooches over by 1 unit,
Okay.
right? Every point. I see.
I'm so confused because mine isn't color coded, so like.
Yeah, so it's a little bit trickier if you don't color code, but you can, like, Taylor, you can still use, like, if you wanted to, you could use dashes. Do the dashes for the graphs. Versus, like, solid lines. Versus do squigglies or something, you know?
Is the red one the one that's like at like in the middle, like at like.
The red one is the one that got cut in half because of the A value.
So wouldn't it be on like 1.5?
Yeah, like it wouldn't be on the actual.
It wouldn't be on
Like,
the
it's
screen, or it's gonna be.
See, like it's
It's at 0.5.
It's kind of thick.
It's, yeah, it can't see. It's like, I can't make it any smaller.
Okay, no, it's good. It's good.
It's at like 0.5. The red one's at 0.5 because the black one's at 1
This is one right here. His dot's right in the middle.
in the middle at half.
On where my finger is.
And same with the red one above that. It's also in the middle.
It's also in the, yeah, the other one's like, the other one was at 4 and then 4 got cut in half to 2.
Yeah.
Yeah. Okay? Now we just got to move it to the right. Every one of those red points gets moved to the right. 1 unit. So this one's going to go to here. This point's going here.
You want brown here.
Okay? Almost done. One more. Okay, and then you guys can work on some stuff.
Okay. Sorry.
Okay? So this is the graph y equals okay? Now I got one more transformation to do. It's to move it up 3. Okay, I'll do it in what color you want, Taylor? Rhetorical question, too slow.
So this one, it's negative, so it should be go to that side, right?
The inside?
Yes.
The inside behaves what? Opposite.
Always.
Positive.
So
Inside.
it's negative, positive, and it's negative, positive, negative.
Okay? Okay, last one will be in magenta. I have to move it up 3, right? So every point on the blue graph now gets moved up 3. Look at this one. 1, 2, 3. 1, 2, 3. Where am I? Oh, I missed the wrong one. Blue one. The blue graph. Okay. What do you mean it's too much work? I only moved it up 3.
You have to count.
Okay. Yeah, you gotta count to 3.
Fine.
Okay. You guys try the last one. Okay.